Hello, everybody. Welcome. This is a video explaining what the hell the JPEG XL art competition is for Inércia Demoparty. I have with me Helmut and WB. Helmut has been doing some JPEG XL art for the past year and a half, and WB is the creator of the whole JPEG thing. He works on development of JPEG XL. So first things first, what the hell is JPEG XL? WB, I guess you're the best person to answer that. So can you explain us summarily what JPEG XL is?
Well, basically, it's a new image format. It's the successor to other JPEG standards, like of course the very well-known first JPEG. So it's intended to have more features in many ways than the old JPEG. For instance, it can do lossless very well. It can also do high dynamic range and so on. But also it compresses quite a bit better than the old JPEG. So it's a successor to the old JPEG, and it's a very recent format. The standard is only published this year, it's still not supported everywhere. Of course, this kind of thing takes a little time. But it has been finalized, and so the format is specified, the standard is out, and we can start to play with it.
So how the hell can you make art on this format? I heard it uses some sort of predictors. Helmut, can you explain this part?
I will start somewhere else. When it comes to size coding, this is the region where I come from. We always care about if you can compress something, no matter if it's data or if it's code. And recently, like the JPEG XL format came to my mind because I saw that stuff patterns like Sierpinski logics, games, and gradients can be very much compressed by a large margin to a density where it's like close to code. So the interesting part about this is when you have Stack Exchange or Code Golf challenges, they tend to develop specific languages just to compress their code better. And it's kind of a cheat because they develop these languages specifically to compress some issues. It will be like, this L means I have an image and this S means I can draw a circle. But JPEG XL is nothing like that. JPEG XL is a standard compression tool. And it happens just by chance or just by the smartness of the approach that you can compress stuff which is demo scene relevant to very, very small chunks. So how can you make art with that? There's a
Yeah,
specific...
maybe give us an example, maybe.
An example, I will just... do you see my screen?
Actually, that's my
Uh,
screen, I think.
well, there are both of them. So I'm showing Helmut's screen now with the
Okay,
Sierpinski on it.
so what you see here is a beautiful editor. It's not done by me. It's done by Surma, one guy of the JPEG XL community. And it allows you to directly write something like an operator tree, which takes some nodes and displays the image. Just to have like, to explain what that does, it takes this tree, compiles it into a file, and then it gives you the opportunity to get this file. For example, this is now a 28 bytes file. So I will just like download it and then dragging it to my Chrome and opening it up. So what you see here is just a normal image file. This is another charming point of the whole thing. Normally, if I have like an x86 program for DOS or TIC80 or whatever, you need some kind of tools for that. Either you need a retro computer or you need like a TIC80 console emulator or whatever. But in this case, the thing you get out of it, it's just the thing you can display. So there's no hurdle for it, which makes it very charming. And let me tell you, this is just a simple example. I think this record of 32 bytes has been crushed by a few bytes now, and it looks better, and 26 or something. But what caught my interest in the first place was I'm pretty good at doing this stuff for x86 DOS. And the programs which produce these kind of images are like in the same size region, let's say. Like between 16 and 32 bytes, you would need to program that as well. So we have an image standard, a new one, which is supported by Chrome as by now and by many other browsers as well. And I think the rest of the web world will follow. And it produces like the same thing with no hurdles to access it, and in better quality because it's a larger image and with the same size. So what you have to do is just to understand what these operators do. And then
Yeah,
you can,
that's the other question I was having.
yes.
I know that it's about predictors, but can you explain for a person who is not used to compression what a predictor is and why do we need a language for that? I guess WB, you might be the better person to answer this.
Yes.
Yeah. So basically, this what we're using here is the lossless part of JPEG XL, and in lossless compression, it's very common to use predictors that basically will inform the encoder what, or the decoder basically, what is the likely next value for the coming pixel, so that what gets encoded is not the actual pixel values but the residuals, so the difference between the predicted value and the real value. And so if the predictor is right very often, then the residuals will be mostly zeros and they will compress very well. That's the general idea. Now, in most of the existing formats like PNG and so on, the predictors are very simple. They are just predict the next pixel as being equal to the previous pixel, or being equal to the pixel above, or being equal to the average of those two, things like that. But in jpegxl, we basically took the concept of prediction and turned it into a much more expressive thing, where basically the predictor itself is signaled as part of the bit stream. And in a way, this allows you to create very small files, because if you engineer them in such a way that the predictor is always right, then the only thing that really needs to be encoded is all zeros. And a file that is completely all zeros compresses down to exactly 0 bits, actually, because we can just signal very cheaply that it's going to be all zeros. So this allows you to create extremely small files that basically are just a description of the predictor, and the rest is just using the predictor to generate the image.
I
And
see.
of course, this is only possible if the language of what a predictor can be is expressive enough. But it is in case of JPEG itself.
Okay. Can you show me a few more examples? Like, why should this be considered art? Helmut, you were explaining a little bit how this goes aligned with the size coding concepts. Can you show me maybe some more examples of other stuff people already been doing?
Yes, so this one, the one you saw, the Zipinski, is a classic, and it's a very simple one. Here I just lined out like a very simple concept of the color channels, which have like numbers of 0, 1, and 2, and you can separate your signal by these channels, and then you can decide what to do if it comes across these numbers, like setting values, and you can also grab coordinates, like what has it to do if x is greater than 500, which is like the right part, and the other one is the left part. So you can play around a bit and set colors. This is just a trivial example, but people have come up with very much artsy things, which
Wow.
I cannot explain in detail right now. This is a very nice one. I think it's of the WB. One of these looks like fire.
Yeah, complicated fire effect.
Yes, so the file is like 64 bytes. So I think I have not come up in my whole career with something that looks as beautiful as that in 64 bytes. That may be an advantage of the approach, but just saying, I mean, normally we brag about that the code density of x86 is the best on the market, so to say. But the beauty of these images is kind of unmatched in my eyes. I mean, I think I can do that in x86, but you know, you have to program it in the way, and you have to come up with FPU and stuff like that. And here you see just I mean it's an acceleration, but just a description of it, and with a very high detail. I always can download the images and show it, but there's more. Like you can, with what I said, with just checking coordinates and deciding what to do when you find coordinates in the image and the color channels, you can print logos, and you can also go for like infinite resolution, so it becomes even sharper on the edges. This is also, I think, most of the work is from WB, because he's very active in that scene. So this one caught my attention because it's very current. It has like a political statement, and it fits in under 256 bytes, which is some kind of a magical border in size coding. And it's just, you know, you have a flag, you have splines which decipher a word. I don't think we can do much better in, like, let's say x86 or TIC80. Then we have some kind of gradient back background noise. It's just 31 bytes, which is like, I think I can't come up with something in 32 bytes in DOS, and it goes on. Like, I have done this in, okay, this is a counterexample because I have done this in, I think, 17 bytes, but 47 is also good for something which has no access for a color palette, because this example has to set the colors all on their own, and in x86 with VGA, you have the palettes already. But this is just, so for some comparison, like, it's on par.
Can we, how do we know, because this is a language, so how do we know what tokens exist in this language? Where do we go to?
There's the button.
Okay,
I mean, you just go on help. You see the smiley. If you're crying, oh, what is all this about? You just click on the help button, and then you have all the keywords which are exposed right now. I think WB might jump in here and correct me, because this is the stuff we know for the tool which we can use. But I think there's more inside the specification, right?
Yeah, there's always more. So this is a tool that allows you to easily create something in an interactive way, and it's a nice sandbox to play with. But it's only exposing, well, it's exposing quite a lot already, but it's not exposing everything that is possible in the bitstream. In particular, it's only exposing lossless, so the modular part of the bitstream. There's also the lossy part that could also be interesting to try to experiment with. There's quite a lot of bitstream features that are a bit harder to express in a simple form. So there is more possible than this in small JPEG XL files, but there is already quite a lot possible with what is exposed here, as you saw. It's quite convenient to have this notation that is editable.
So for Inertia, what are the rules specified specifically? Like you're supposed to only use this editor? Can you use other rules outside this? Can you do animated stuff?
The only constraint is it has to be a valid JPEG XL file that decodes with a standard decoder, so that it's not a corrupt bitstream, and it has to be less than 512 bytes, which should be enough given what you can do in quite a lot less than that already. You can use the editor, and I recommend to at least first play with that one. But if you want to directly craft the bitstream in some other way, it could be by hacking the software encoder and making it do something, or just by doing it in a hex editor, which will be tricky, but I don't want to discourage anyone. Then you can do that as well, as long as it's a valid JPEG XL file. For this contest, it's only still images. JPEG XL can also do animation, but I think we for now let's start with still images. It's interesting enough already, and they will be shown at landscape resolution, landscape orientation on a full HD screen. So that's probably important to take into account. There's maybe one thing that I should mention here, which is in JPEG XL, the images are divided into groups or tiles. The limit, the maximum size for each group is 1024 by 1024. So that's also the default size that is used in this editor. So if you want to do full HD, you could change the resolution like this.
Should I share your screen?
Yes, maybe share my screen. So if you specify the width and the height of the image, you get this. The thing is, this image will be composed out of two groups now, because the group size is not that large. So okay, if I make a simple program, for instance, that says if x is larger than 0, then take the pixel to the left, so to the west, and add 1. Otherwise, so on the first column, set it to 0. So this will give you a gradient, except you will get it twice because this will be done for each of those groups, which is maybe not what you want. So of course you can also select based on the group and do something like, and this is a bit complicated. If the group is the one on the right here, and this numbering is a bit strange, but let's go with it. I can, for instance, set it to white, and otherwise I do the gradient thing. Now it will be a bit better. Actually, this image has 4 groups. Like you see, the height is a bit larger than, so you get this effect. One easy way to circumvent that problem is to work at a lower resolution than the one that is allowed, like half of it.
Yeah, if you stick with 1024 by 1024, you should be not having to deal with those things.
Then you don't have to deal with it. But also, if you do it like this, then the aspect ratio will be fine. And if you want to have more pixels, you can upsample it by a factor of 2. And then the actual image will be exactly
pixelated,
well, it's not. It's a nicer upsampling than just
okay.
Than what typical upsamplers do. That's one approach, or you could have, of course, the larger image, but then you have to deal with the multiple groups. You can also adjust the group size if you want to have smaller groups. You can do, I think it's called group shift. So if I use groups of size, the minimum size, then I will have a lot more groups, as you can see. So you see there's quite a few groups now. Anyway, this is a weird effect.
Okay, starting to get a bit into tech territory. So main question is, people might be interested in doing this. Where do they go to find help? You already saw this editor, which I will post on the description. I believe there's also a Discord that they should join.
Yeah, there is a jpegxl Discord that has a channel devoted to jpegxlart, so people can definitely ask questions there and hopefully get answers.
Okay, cool. As well. I think we are pretty much done with this video. Almost 20 minutes. I think it's a good length for people. WB, any last words? Any calls for action? I guess don't forget to participate at Inércia.
Well, yeah, I have one.
I'll go to you next, Helmut. Don't worry. Okay, I know you have a lot to say, but WB first.
Yeah, I'm curious what people will come up with. I think there's lots of things to be explored still, and basically one thing that this can do is almost any kind of cellular automaton can basically be represented in this way. And like Sierpinski is a simple example of it, but there's also more complicated types of cellular automata that can be described. And so, yeah, maybe there's new things to be discovered here. But also, you can just artistically try to create something. The budget of 512 bytes should be enough to do some splines or other things that you basically manually draw. So I think there's many options, and I wish everybody good luck.
Okay, thank you. So Helmut, big final wrap up. I saved it for you. Why is this relevant to the demo scene? I know you were very vocal about this on a Poet thread about a year ago when this first started to come up. You were like, "Oh, this is awesome," and Garguy was like, "No, this is not it's not for Poet. There's no demo scene compo about it." And I wanted to add one on last year's Inércia already, but then we already had too many compos. But this year it made sense to have again, and I wanted you to be present on this video so you can vocalize why you think this is relevant for size coding, and how do you see having art on this specific format?
Well, what we have seen so far is in the best versions in the regions of 32 or 64 bytes, and I think we can we are on par in x86 domains, not TIC80. That's too large for that. But the point I see is that normally we try to pitch our x86 or our TIC80 stuff or whatever, or ZX Spectrum, and tell new people to join the scene. And they are like, yeah, but I have to get stuff, like I have to get hardware, and I have to get, to get into the mood or to be able to participate in any challenge, you have to learn so much. And we set up a wiki, we have our own Discord, we try to tell people this stuff, but so far people like don't bite, not the new ones. Like the old ones, of course, they come back and they do their things, which they've always done. But it's like there's a huge hurdle, and this is not so much with the JXL. First of all, it's the outcome of this thing is something you can use in your everyday life. So it's not like I have a beautiful cellular effect and I want to show it, and people are like, "What do I do with it with a comp file?" And then, yeah, you have to get a DOS box. And what is a DOS box? And yeah, it's an emulator for an PC. What is the 386? They don't know about that. But the outcome of that one is specifically an image, and you can load it into a browser. And we don't have to stop there. Like, if you think about JavaScript demos can load an image. You can just take the image and use it as a background for your demo. Like, have a beautiful gradient and like 120 bytes. That's almost nothing for a 1K demo. And then, like, let Sprite dance in front of that. So the main point I see is like the accessibility is just that's a huge advantage of the thing is the accessibility, and also the code density. What you write is so small that only very experienced machine language coders can be on par with that. And you don't have to like really program something, you can design it. You have your splines, you can do letters, you can do flags, and in 512 byte you can do so much. So basically for a size coder, or let's say for a size coding designer, there's no excuse to not do it, because it's a public tool, it's available, it's just one click away, and you can share the outcome in a form of the text file, like the description of the predictors, or the image just by a finger snip. So that's all there's to say. Like, I challenge all our size coding friends to join the competition, because if you can do something in x86 in 256 bytes or in 512 on a TIC80, then you can do this one as well. I mean, it's the same. It's just you describe your cellular automaton, you describe your structures, and you just hit the run button, and the compiler or whatever the packer does the rest for you, and you have your result. And boom, you can change it and you can use it everywhere.
How restrictive do you feel the size is for this one in particular? Do you think it allows
This
you to
one,
do whatever
this
you want, or?
it's almost limitless. It's like, I mean, I don't know what the technical limitation is, but in 512 you can do a lot. I mean, there are beautiful effects like I think the most famous one, which I already showed, the sky gradient with the mountain and the lake before that, and the landscape. That is 120 bytes. So just imagine that with, I don't know, with trees in front of that, or whatever you can come up with when you use the predictors. So in 512 bytes, there's a lot of possible. And even if you don't care about like having the most density, then you can just freely explore like splines or text. You can do logos for the next party. You can just do a party invite. Just do a party invite for Love Byte, do a party invite for the next function or whatever, because letters are apparently no problem to do in this thing. Yeah.
Okay, excellent. Thank you so much. It's already past 20 minutes, so we should probably wrap this up. Everybody, please, I invite you to participate on this competition at Inércia Demoparty. It's the first time, well, there's been a competition for JPEG XL art before, but it's the first time we have it on a demo party, and it would be cool for the demo scene to embrace this sort of art competition as well. As you've seen, it has a lot of similarities to other demo scene stuff. So welcome everybody to participate. Hope this video was useful, and you can find all the links on the description. Also join the JPEG XL Discord if you want to know more or talk with other people who are trying to do something for that. That's it for me. Also, I guess goodbye also in the name of Helmut and WB. Bye-bye, everybody. Make some entries for Inércia. See you next time. Take care.
Bye-bye.